In this video, I will discuss some NEET PYQs from the topic Motion in a Plane. Timestamps are given in the description box. You can watch parts of video if you are running short of time. I'll discuss some 5 questions. This is the first one. A body is whirled in a horizontal circle of radius 20 centimeter, has an angular velocity 10 radian per second. What is its linear velocity at any point on circular path? 4 options are given. This is a simple question. You can pause and attempt it. Body is moving in a circular path of radius 20 centimeter and the angular velocity is 10 radian per second. So it's moving like this. So at any point, it will have a linear speed v, which you have to find out. So you have to use the formula which relates the linear velocity to the angular velocity as v equal to omega into r. You can have an understanding of this formula. Time period of this motion. Time period is a minimum time after which the motion repeats. So here the time to go from here to here, finish the circle is the time period. After it's going to repeat the same motion. So time period is the time it takes to move from any point, finish the circle and come to the same point. So this time period can be written in 2 ways. One is the distance traveled when it goes around once, that is the circumference 2 pi r, and the speed which it moves, that is the linear speed v. The same time period can be written as the total angle covered when it completes one circle, that is 2 pi radians, which is 360 degrees, but you have to write in radians. So complete angle it covers when it makes one full revolution is 2 pi radians, and the speed which it covers the angle is omega. So both are equal. So 2 pi can be cancelled. So from this, we get omega into r is the velocity. So that's how we get this formula. So here, omega is given 10 radian per second and r is 20 centimeters. So to convert to SI units, so it will be 20 by 100 meters. That will be the linear speed v. Simple calculation, 0, 0 can be cancelled with 100. So it's 2 meter per second. So option B is the correct answer. Option B is the correct answer. So this is what is explained here. Radius of the circular path is given as 20 centimeters in the question. That's in SI units 2 by 10 meters. Angular speed, it's also given in the question. 10 radian per second. Linear velocity related to angular velocity as v equal to r into omega. V equal to r into omega. So this thing can have an understanding because the time can be defined in 2 ways. One is the circumference, you have the linear speed, and the total angle it covers in one revolution is 2 pi, and it covers the speed of omega. So distance by speed is the time. So that can be calculated in 2 ways. One is the linear distance by linear speed, angular displacement by angular speed. So from this you get the relation v equal to omega into r, and using this thing we get linear speed as omega into r. So that will be 2 meters per second. This is the next question. two particles A and B connected by a rigid rod. The rod slides along perpendicular rails as shown here. The velocity of A to the left is 10 meter per second. What is the velocity of B when the angle alpha is 60 degrees? So the length of the rod, let me call it L, which is fixed. It's not going to change. So, and let this be the x-axis, and let this be the y-axis. So this x-coordinate of the point A is x, and the y-coordinate of point B, let me call it y. So velocity of A, which is moving towards left, as it moves towards the left, x is going to decrease. So it will decrease at a certain rate. It's dx by dt. So that is related to the rate at which the x is decreasing is the velocity of this point A. But you have to put a negative sign here because x is decreasing as time increases, and velocity of A is a positive quantity. Similarly, velocity of B, coordinate of B is y. So it's dy by dt with a plus sign because as A move towards the left, B will move upwards. So y is going to increase. So it's plus dy by dt. And the relation between x and y is constrained by the length of the rod as x square plus y square equal to L square. This got by applying Pythagoras theorem in this triangle. This is a right angle triangle, perpendicular rails. So this is the constraint relation. Now if I differentiate this on both the sides, I'll get 2x dx by dt plus 2y dy by dt. As time goes on, this thing is moving this way, so x will change, y will change, but L will not change. L is a constant, so it is 0. Two can be cancelled, and this is x into dx by dt is minus va plus y into dy by dt is vb. So from this I'll get vb as, you have to find vb as x by y va. Take this term to the right side, and x by y is y by x is tan alpha, so this I can write as va by x. I can take the denominator, become y by x, which is tan alpha. va is 10, tan alpha is tan 60, which is root 3. So 10 by root 3 is the answer. So this can be written as 10 root 3 by 3. Root 3 is 1.732, so this is nothing but 17.32 by 3. This we can calculate. 3 5s are 15, and then 23. 3 7s are 21, and then 22. Again 3 7s are 21. So this is in SI unit, so it's meter per second, because 10 is in meter per second. So it's 5.77 meter per second. You should know how to do approximate calculations. 10 by root 3 means you should not get stuck. You should rationalize. It should become 10 root 3 by 3. Once you get this, please do the division, because root 3 is 1.732. That's a standard value, which you should know. So answer is 5.77, which is approximately 5.8. So this is what I explained here. The rod has got length L. Let it be some fixed length L. And let me call this is x-axis, this is y-axis. So it coordinate of this point A is x. And the y coordinate of point B is y. So as the thing moves towards the left, x will decrease. So minus dx by dt is the velocity of point A. And as the thing moves to the left, y will go up, or the point B will go up. So velocity of B is nothing but dy by dt. The constraint relation is x square plus y square is L square. This is for constraint relation because when x changes, y has to change in such a way that this relation is valid. Both x and y cannot change arbitrarily. It has to change in such a way that this relation is satisfied. So that will put a constraint on the values x and y can take. So this is why called constraint relation. So we differentiate both the sides with respect to time because we have dx by dt and dy by dt, and we have to find dy by dt. So differentiating, we get this one. So simplifying, I'll get the value as 5.77. It's approximately 5.8. This is the next question. 6 vectors A through F have magnitudes and directions indicated in the figure. Which of the following statements is true? So only one statement is true. We have to find which one is that. So right hand side are called F's. Left hand side is two vectors which will add to give F. So F vector is like this. So if you think in terms of components, it has got a horizontal component towards left and vertical component going upwards. So this can be split as sum of two vectors. One is horizontal vector, other one is upwards. Horizontal vector towards left and upward vector. So this is given a parallel law of addition. So this is so the left vector which is pointing towards left is E. So E can contribute to F, and upward vector is D. So E and D can add to give F. So there is only one vector which is pointing towards left, which is E. There is no other vector, and there is only one vector pointing upwards, that is D. So D plus E should give F. So that is option C. C is the correct answer. This is the next question. The push vector of a particle is R equal to A cos omega t I cap plus A sin omega t j cap. The velocity of the particle is, four options are given. Option A, directed towards the origin. Option B, directed away from the origin, parallel to the pushing vector, perpendicular to the pushing vector. So you'll find the velocity. So velocity, the basic definition is V equal to rate at which the displacement is changing. So V is dr by dt. So to differentiate this thing term by term, I is a constant vector, A is also constant. So A derivative of cos is minus sine. And differentiate with respect to time. So you have to differentiate this omega t. So that will give me omega. So this into I cap plus the second term A derivative of sine is cos, and then omega, because you have to differentiate this thing with respect to time, because derivative with respect to time, into j cap. So given two vectors A and B, I can write the dot product as AB cos theta, where theta is the angle between the two vectors. So this will give me cos theta as A dot B by AB. So if you calculate this quantity, I can get the value of the angle theta. So in this particular case, if I do R dot V, it will be A square cos sine with the minus sign here, I cap dot I cap is 1, and then plus A square, this term dotted with this term, so A square sine and cos, and then omega is also there. So these two terms will cancel, so I'll get 0. So left hand side is 0, that means cos the angle between these two vectors is 0. That means theta is 90 degrees or pi by 2 radians. Basically, they are perpendicular to each other. So velocity vector is perpendicular to the position vector. So option D is the correct one. So position vector is given in the question as a cos omega t I cap, a sin omega t j cap. Velocity vector is dr by dt. So differentiate term by term. A is constant, omega is constant, I is constant. Only this t variable is there. So differentiate of this one will give me a. Derivative of cos is minus sine, and differentiate with respect to time. So I have differentiate this omega t with respect to time. That will give me omega. And differentiate of this one will be a omega cos omega t j cap. So come like this. So there is a, so you can do a dot b. So r dot b is 0. That's equal to the cos of angle between r and b, which is 90 degrees. There's another way that can do this problem. Slope of this position vector is y component by x component. So that is tan omega t, and slope of this velocity vector is y component a cos omega t by x component minus a sin omega t. That will give me minus 1 by tan omega t. So slope, if it's negative reciprocal, they are perpendicular. So this is negative reciprocal. So these two vectors are perpendicular to each other. So velocity and displacement are perpendicular. This is the next question. A projectile is fired from surface of Earth with an velocity 5 meters per second at an angle theta with the horizontal. Another projectile is fired from another planet with a velocity 3 meters per second at the same angle and follows a trajectory which is identical with the trajectory of projectile fired from the Earth. The value of acceleration due to gravity on the planet is in meter per second. Given g is 9.8 meter per second. G is acceleration due to gravity on Earth. So projectile motion will look like this. See on Earth. On the planet also, it's exactly same. So if I keep on this top of this one, it will be exactly matching. So one of the things that should match is the horizontal range. Here the horizontal range is h. Here also the range should be same. And the formula for horizontal range is u square by g sine 2 theta. So the horizontal range on the Earth is, we have to put ue by g sine 2 theta. Theta is same for both the trajectories. Same angle. So this should match with the planet trajectory on the planet, which is up square by gravity on the planet. Theta is same, so it will cancel. This and this are exactly same trajectory, so H should match. This should be same for both Earth and the planet, and theta is same for both Earth and the planet. It's given in the question. So theta will cancel. So this thing should be equal. So ue square is phi square. This one, and g on Earth is 9.8. That's equal to u on the planet 3 e square by g on the planet. That's what you have to find out. So gp is 3 by 5 whole square into 9.8. So to do this calculation, 3 by 5 is same as 6 by 10, so it's 0.6. 0.6 square is 0.36 into 9.8. So 9.8 I can write as 10 minus 0.2. So 10 times this 0.36 is 3.6 minus 0.2 is nothing but 1 by 5. So this divided by 5 is 0.07. 7 5 is 35. And then 10. So 0.72. 0.2 this one is 0.2 is 1 by 5. So this divided by 5. So 0.07. 35. And then 10. So it's 0.2. So this one 3.600 minus 72. Oh, rather 6000 minus 72. So it is 6000 minus 72. So it's 8. 9 minus 2 is 7. 5. 528. SI units meter per second square. So it's option A. Option is the correct answer. So trajectory is identical for both. So horizontal range should be same. So u square by g sine 2 theta should be same for both Earth and the planet trajectory. So from this you'll get this ratio is this one. So this will be approximate calculation and get the answer as 3.5.